Okay, we are talking about electric circuit today, and in this electric circuit, we will be working with a very small, a few number of components: R, which is resistance; I, which is the electric current; and V, which is the source of power. So R is a unit is expressed in ohms, or you can just write ohms. Um, I is expressed in amperes, so that's capital A, and V is in volt. So we're gonna use the very useful equation called the Ohm's law. So Ohm's law is a V equals R times I. So again, you have to use exactly these units V, A, and ohms. So if you are given a volt in millivolt, you have to convert it to volt before you do the calculation. Electric current in milliamperes, you have to correct it to convert it to amperes. If the resistance is in kilo ohms, mega ohms, you have to convert it down to always to the single units. So from this equation here, we can derive, for example, that R would be V divided by I, and same thing, I equals V divided by resistance. So if you know, for example, the voltage, the current, then we can determine the resistance. If you know the voltage, you know the resistance, then you can determine I. And of course, the Ohm's law, which is V equals RE. If you know the resistance, if you know the current, then you can figure out the voltage value. Now, I will start with very simple circuit, and we try to make it more and more difficult. So a very simple one. Let's say that we have this circuit here. So the EMF again. EMF stands for electromotive force. The larger electrode is positive, the shorter electrode is negative. And let's say that we have here a resistance. The resistance is like a zigzag line. And then we have down here a switch. We put always a switch, sometimes a fuse, but for now we simplify it with the following figure. Okay, so let's say that our voltage here, source of power, is 24 volt, 24.0 volt. So let's keep three significant figures. Our resistance is 12.0 volt, 0 ohms. And the question is, what is the electric current? What is the electric current value? So this is once you close the switch here, this is very important that you understand how would you draw the direction of the electric current. So the electric current is going out of the positive sign. Then you draw the arrow. I put it on the wire, but it could be above or below. And this is your electric current. So since there is on this side there is nowhere else to go for the current, so we have to keep going. So it has to pass through I like this. and then in this direction, and coming down to the negative side. So that's, you need to know how to draw this structure, to draw the direction of the current. So we said that what is, if you are solving for I, so we just use this equation here. So I equals V, which is 24 volt, divided by the ohms, the resistance, 12.0 volts, and that will give us I equals 2. Keeping the same significant figures, 2.00 amps, and this is how we use Ohm's law. So that's to make sure that you understand how to use Ohm's law. Ohm's law is about 3 parameters: voltage of the EMF, electromotive force, resistance of the resistor, which is represented by the zigzag sign here. We have seen that in the previous part of studying the components, and the I is the electric current. You don't show I in a circuit. I is something which is, this is the flow of electrons inside the circuit. Okay, so I will draw another one, but to solve another problems. So we're gonna start with the circuit again. So it doesn't matter if you have 2, 3 of these. This is always the same, the EMF I'm talking about. So let's say that we have the switch here. I'm gonna put here my resistance, and we're gonna close the circuit right there. Now let's assume that we have a voltage of the source here, the EMF. Let's say we have 6.0 volt, and that we have here a current of 1.5 amps. And so I draw again the arrow is from the outside, plus outside, and you just go this way, and you close it. So that if I draw so once you close the switch, if I draw here the electric current, that would be in this direction. If I hear the electric current, that would be in this direction. So again, you can go over the wire or just inside the wire. Now question, what is the resistance value? Again, to solve the problem, very simple, use Ohm's law. Ohm's law is V equals R times I. So from this, you can get R equals V divided by I. This circuit here, that's the very simple one. We have 3 parameters. Again, the source EMF. EMF is the voltage, the electric current, and the resistor. If we can change the circuit, the complex circuit, into a simple circuit like this, then we can always solve the type of problems. So let's solve for R. R is in this case a voltage, 6.0 volt. We divide by 1.5, which is the amperes, the electric current value. So when you do the calculation, we would end up with 4. So that means, keeping the 2 significant figures, this would be 4 ohms. Okay, so just again remember, when you do the calculation, you have to keep exactly your units as volts, amps, and ohms. If it's different from that, you have to do some conversions. Okay, we go to the next presentation, which is more complicated.